Hello everybody, welcome back to the next jam session for the FP101 course. And what we're going to do this time is to look at functional programming in Dart. Dart is a new language from Google aimed at programming web applications, and Dart has great support for functional programming. If you come from Java or from C#, you will feel immediately familiar with the Dart syntax. And if you have followed the Haskell lectures, you will be able to take all the things you learned there and immediately apply them to Dart. So let's open up the editor and play around with Dart a little bit and see how we can apply what we learned. One interesting aspect of Dart is that Dart has optional typing. So it's not statically typed, but you can put in types as you want to. So it's not like JavaScript where it's completely dynamically typed. There's no way to put type annotations. And I must say, in practice, this works out very, very well. The nice thing about Haskell is that the Haskell type inference is very powerful. And so you never have to write any types yourselves, and typically the compiler will be able to infer things for you. But the price you pay for that is that you have to, there's a couple of things in Haskell where type names have to start with uppercase symbols. When you have type classes, you use a name in there. It's kind of used forever. You cannot have that in a different class. And in Dart, it's a little bit more, hackerish. And I like that. So let's open up IntelliJ. I'm using the Dart IntelliJ plugin. You can download that plugin from the IntelliJ website. You download the Dart SDK from the Dart website, and off you go. So, like most languages, Dart also uses a main method. So we see here the main method. We don't have to specify whether it takes any arguments. And then here we just print hello. The next line here shows a lambda expression in Dart. So I'm defining a variable f. And its value is a lambda expression, lambda x, x plus 1. So here you see that this thing has a function type. And let's just try to say f plus 3. Let's see what it does. And now you see, and you cannot see that, it's quite small. I don't know how to blow up the type hints, but I will read it for you. And it says, there is no such operator plus in function. So even though I didn't put a type on f, the compiler has inferred that f has type function and that there's no addition operator for function. But, it will just let me continue. And if I want to do this, it will let me do it because the typing is optional. Okay? But I'm not going to do this here, but that's the beautiful thing. So the type inference tracks the types, but nothing is forced on you. The compiler will never slap you on your wrist and say, Eric, you cannot execute this program. Okay, so here we have our function, and we can call it with 3. Now let's define another local function. That's another nice thing of Dart, and we saw that in other languages like Scala and Kotlin as well, is that inside a function, you can define a local function. So here, inside main, I'm defining a local function, a g, and this g can refer to this outer variable f. So it closes over f. And what g does is it calls f of x and then multiplies it by 2, and then here I print g of 4. Now let's look at a real higher order function, our good friend twice. So twice takes two parameters, f and x, and I call f of x. So you see here, this looks just like the lambda expression in Haskell. And if I wanted, we could also define it like this. We could define var twice equals, and now, it looks like the lambda expression form in Haskell. And if we do it like this, it looks like the function definition in Haskell, except that there's an arrow here. If you don't like the arrow, you can use what we already did here. We can put the body up. Type correctly. We take the body and we say return of the expression, and then in here we can do other interesting things. So, for example, we can do print that we're executing f. So we can mix and match imperative code with higher order functions. Good. Let's run our program and see if everything works as advertised. So let's go from the top to the bottom. Let's first run the program and then check. Wow, that's really quick. The Dart VM is really fast, and the implementation in IntelliJ is extremely responsive. So here we say print hello. So on the output we expect hello. Then we defined our function f. We print f of 3. That should return 4 as expected. Then there's g of x here that doubles f of x. So that should be, if we call that with 4, g of 4 calls f, that's 5, that should be 10, there we go. And now here we see that we're inside twice, we print ... and then twice of incrementing 3 twice gives us 5. So that's all as expected, and there's a lot of things in Dart that I didn't show, but one of the things is that Dart has classes, and the nice thing is Dart doesn't have a separate notion of interfaces. It's unified with abstract classes, so there's less syntactic baggage. In languages like Java or C#, there's abstract base classes, interfaces, whatever. And in Dart, that is simplified. Let's go here. The other beautiful thing of Dart, if we go here and we let's go here, there we go. If we go to the Dart language specification, the Dart language specification is written by Gilad Braga, the same person that wrote the Java language specification. And it's a very, very thorough description of Dart, explains everything. And the beauty of Dart here is that Dart now supports new features, async and await, that we are familiar with from C#. It also supports so-called sync star methods, which are iterators that we know from C# and Python, and other languages such as PHP also support iterators. But the real nice thing here is that Dart also has support for streams, for asynchronous data streams, which is kind of a combination of async await and the sync, the iterator style of programming. And with these three features, I think Dart is ahead of the game with respect to other programming languages, because it has full support for both asynchronous methods, methods that return synchronous collections, and methods that return asynchronous collections. So I invite you to kind of take a look at Dart. there's also a Dart to JavaScript compiler, so you can run Dart in a regular browser. You don't need the Dart VM. And if you want to write web applications and you come from a Java or C# background, I think Dart is a fantastic choice. And thank you so much, and see you next time.